But the first question was, what do we have to know from chapter 5? Remember we did section 1, and not all, but some of section 2. So, given any molecule, any compound, you should be able to tell me if it's a strong or weak electrolyte. So any compound I give you, tell me if it's a strong or weak electrolyte. That's the first definite thing. The second definite thing, there's really 3 things you should know. Second definite thing is using solubility rules. I will give you solubility rules on the exam, but whatever molecule I give you, you should be able to tell me if it's solid or aqueous. Okay, so does it precipitate or not? That's the second thing. Third thing is you should know the standard conditions. So both solubility rules and standard conditions are on page 33 for the reader. Everything on that last table at the bottom of the reader. So for example, O2 is a gas. CO2 is a gas. Noble gases like helium is a gas. Stuff like that. Okay? So those 3 things. We didn't quite get to net atomic equations, so that'll be exam 2. Alright. Next, yes? Okay, yeah, tell me the page. Number 4. Page 4. Oh, you meant page 4. Okay. So I'm looking at practice exam reader. I'll tell you the exam year in just a second here when I get there. Okay. This is winter 2013. So last winter, number 14. Okay. All 3 of them?
I just have a question, because in the notes it says strong electrolyte are usually aqueous, but then 2 out of the 3 of those are aqueous, but the answer is still true.
Okay. Yeah, that's true. So a strong electrolyte that tends to be aqueous. So a lot of aqueous things are strong electrolytes, but not all. And there's a couple exceptions. And the main exceptions are, well, so the first 2, only the first one's aqueous, right? HF, hydrofluoric acid, that's the only aqueous one? Okay, so HF, that's aqueous, so you might think, oh, aqueous, strong electrolyte, but except if it's a weak acid or a weak base.
How do you know if that's
HF is a weak acid, and you'll learn that in, I think, section 3, which we haven't covered yet. So, in the case that we hadn't covered it, if I was going to give you this example, I would say HF, comma, weak acid. So then you know it's a weak acid. You will learn soon enough how to know that it's strong or weak. Is that, did you want to do the other 2 or you're good?
The last one.
The last one, AgCl. Okay, so you think ionic compound, but it's only the ionic compounds that are aqueous. Not the solids don't count, or all solids, liquids, and gases are not. If you look in the solubility rules, bullet 2 of the solubility rules, let me see if I have that handy. Here. Right here, and this will be on your exam. Bullet 2. Halides, you usually think they're aqueous, except for the following 3 exceptions, and He plus is one of those exceptions. And you don't have to memorize it, just make sure you look at it carefully, because there's a lot of exceptions in here, as you can see. Okay, cool. Who's next? Yes? Second practice exam. What year is that? Okay, and what number? I'll look for it. Oh, whoa. Okay, this is not looking good. Oh, you have the question. Okay. There's not a lot of words in here. This is what it says. Let's see. Oh, in here. Oh, yes. Okay. Okay, yeah, I remember that question vaguely. That's, for those of you who are looking at it. Okay, I can't. So, but for this compound, what's the oxidation state of oxygen, right? Yeah. So, for oxygen, how would you answer that? -2. Done. For oxygen? Okay. Oh, you don't? No math necessary. necessary. Oxygen is -2. There's 2 exceptions to that. Remember our flow chart that we went through in the notes of how to tell what the charge is of something? Oxygen, with rare exception, is going to be -2. That was in chapter 3. And let me just find it so you can reference it. This is what I referred to, page 20. Usually oxygen is -2. So I wouldn't do math if I asked you about oxygen, hydrogen, or any of these. And the only exceptions to that are as follows. O2 gas. What's the oxidation state of this, anybody? This would be 0, because 2 times 2 oxygens equals the overall charge of 0. So it has to be 0. Divided by 2 both sides, still 0. Okay, the other exception is what's called a peroxide. And the peroxide ion is actually in your polyatomic list in the reader. It's this one. You ever see this one here? Let's try this one out. Okay, if I want to find the charge of this, 2 oxygens equal the overall charge of -2. So oxygen is -2 over 2 or -1. So if you ever see a peroxide, some examples would be like this, and O2 something typically, where it's O2 2 minus, or there's not a lot. I guess this would work. Something, you see that signature right there, which is this compound. Those are the only 2 exceptions to the -2 peroxide. Is that okay? So no math necessary on that one. Good question though. It's good to know these exceptions. Yeah. Yeah, so each H is +1 for a total of +2. And each O is -1 for a total of -2. She was asking how did this work out? So each H is +1, each O is -1. If you did -2, it wouldn't work in here. Yes?
Hi, did you do the first example on page 28 of the reader, please?
28, number 1. Or, do you mean the, wait, when I go to 28, I get this. The other kind of reader, not the practice exam. 28. There's no examples. Oh, this one down here? Yes. Okay. This is a type of molarity question. Conversion question within molarity. And the first time you see it, it looks as weird as it does right here. But after you see more than one, you'll see, oh, when you get these, they're identical every single time. So in this case, I have a 36% solution of HCl. So you'll see a percent in this kind of problem. You also see a density given. In this case, it's 1.19 grams per milliliter. That's really common. Both those really common. Okay, then what they want you to do is convert this to molarity. So this is a literally conversion problem. And so you take, really you can start with either one of these. It doesn't really matter which one you feel like starting with. Just to follow what I did in the reader, I'll just start with that one. So you got 1.19 grams per milliliter. Now this density here, whatever density is given, and it states, it doesn't totally state it here, but you should know when a density is given for kind of a whole compact solution, it is literally the solution density. You're going to see why that's going to be important in just a second.
That's percentage by mass or volume?
By mass, yeah. There are percents by volume, but we really don't get into that in Chem 2A. Yeah, so all the percentages you'll see will be percent by mass. And typically, if it's not labeled, it's percent by mass. Yeah, even in 2B and later. Yeah, because it's the most common percent you'll see. Okay, now what was I up to? I am converting this to moles, right? Okay, or molarity, which is moles per liter. So I want to change the top, eventually has to change to moles, the bottom has to change to liters. I think the bottom looks easier. Let's change that one first. There are 1,000